Hello and welcome to the Unisky training platform. Do remember to subscribe to my YouTube channel for more videos. Godfrey Yaka. Thank you. In today's tutorial, we would be looking at a routing protocol known as the OSPF, which is the Open Shortest Path First. This allows for routing pools or routing policies on a network to define the shortest cost or to define the appropriate path for a specific service to be delivered on a network. So to achieve this particular task, it is assumed that you are a network administrator of a small enterprise, and it's required that a network be implemented using OSPF. The network is to support a single area, and with consideration for future expansion, it is requested that this area be set as Area 0. OSPF is required to advertise default routes and also elect both a DR, which is the designated route, and a BDR, which is the backup designated route for network resiliency. Now, the objective of this particular study is to 1. Configure a router ID for our OSPF, 2. Establish OSPF for specified interface or say a network. Then 3. View OSPF operations using display commands within our router. Now, the Open Shortest Path First is a classless routing protocol. This means that in its updates, it includes the subnet mask of each route it knows about. So there are lots of routes on your network, but it includes what is defined within the OSPF terrain. So this enables variable length subnet masks. With variable length subnet masks, an IP network can be broken into many subnets of various sizes. This provides network administrators with extra network configuration flexibility. So it allows for you to make your network very flexible, such that when a delivery of service or information is needed, a computer does not wait in queue to pass through maybe a very long process, but it can easily calculate or evaluate a cost between the various paths defined in your area, that is your OSPF protocol, in order to deliver the information or service to the said computer easily. So the topology we would be looking at is this. We will be dealing with 3 different routers, router 1, 2, and 3, where we have router 1 connecting to router 3 on port 0 from router 1 and port 0 on router 3, which is a 0/0 port gigabit port. Then from router 1 port 1 to router 2 port 1, also on the gigabit port. And now we would define loopback interfaces, because we are using a simulator. We are not on the physical environment where we would have the physical interface connecting our router to an external network or maybe a broader network somewhere. So the loopback interface is going to define maybe an external network connected to our router before it is able to communicate with any said topology or any said protocol we are defining. So the block of IP addresses listed here is what we will be using to configure our routers. So in other videos, I already took you through how to configure your topologies using the ENSP platform. So we simply configure our topology with the router 1, router 2, and then router 3. And then these are definitions of the IP block addresses we'll be using, but we would have to log in and then configure, say, the router name and then the interface addresses as we saw in the presentation. So from this particular presentation, we would use these IP addresses indicated here to configure our routers. So let's start with router 1. So from router 1, we are in the global view. Anytime you see the router name in 2 shapes, like the greater than and less than shapes, that is the global view. But if it is in the square brackets, it means you are in the configuration mode. And to switch to the configuration mode of a router, you simply type system-view. This takes us to the configuration mode of a router. So to change our router name, we simply say sysname, and then our router name is what? RT1. So I would want to display the block of IPs as we configure, so that we would see that we are actually doing the right thing. Now that our router name is configured, we go ahead to set the IP addresses for the interfaces. For router 1, in this particular scenario, we are assigning 10.0.13.1 to its 0/0/0 interface. So we navigate to it. So we say interface, the gigabit Ethernet port 0/0/0. It takes us to that particular port, and then we define its IP address. So we say IP address. We use the tab key to complete a command halfway through. So we define 10.0.13.1, then space. Then we define the number of bits for the subnet mask, which is 24, and then I hit enter. So it updates our router, and then we go to the next interface. So we navigate to the next interface by saying interface. Of course, you just like in every command prompt or a terminal as in the Linux systems, if you use the top arrow key, it returns the command you previously entered. So all previous commands can be accessed by using the top arrow key. So I just hit the top arrow key to say the interface, and then I simply change here to port 1, and then I hit enter. So it navigates to gigabit Ethernet 0/0/1. Now we can enter our IP address, which is IP space address, and then I enter my IP address, which is 10.0.12.1 space the subnet mask of 24 bits. Then we give it some time to update the router, and then it's done. So let's create our loopback interface. Now the loopback interface is a virtual interface we are creating on the router. So we simply say interface, then loopback 0, because we are creating the default loopback interface, which is 0. We could name it 2, 3, and so on and so forth, depending on the number of loopback interfaces you want for your router. In this case, we want a loopback 0 for router 1. So we simply say this, and you see it has created an interface called loopback 0, and it has put it against the router 1 in our square bracket. So this allows for us to assign an IP address to this particular interface. So we say IP address 10.0.1.1 for our loopback, and then our subnet mask of what? 24. So this sums it up for the configuration of our first router. Now we want to see if all the information we have entered has actually taken effect. So the best way to do that is to display a brief of our IP addresses. So we simply use the command display IP interface brief. So this spells out all the interfaces on our router device, and then it spells out that on gigabit Ethernet 0/0/0 it is assigned 10.0.13.1, and the next one is 10.0.12.1, and finally our loopback is assigned here against our previous or existing network cards on the device. Then we have 10.0.1.1. So this sums it up for router 1. So we simply navigate to router 2 for its configuration. So I maximize this so that you can easily see that. Then we want to see alongside what we type. So system view would take us to the configuration view of our router. Then we change the name of our router by using sysname rt-2. It changes it to what? Router 2 in this particular scenario. So we are going to define our IP addresses for interface 1 and then the loopback interface. You realize that router 2 only connects from one particular interface through to the other router, which is router 1. That is why we need to configure only that interface, and we add our loopback interface. So we simply navigate to interface giga 0/0/1. Then we define the IP address, which would go at 10.0.12.2. So 10.0.12.2. Then the subnet mask is what? 24, which is our class C IP address. Then we hit enter if we are sure of what we are doing. Then now it accepts this particular change, and now we create a loopback interface for this router too. As we did in the previous router, we simply say interface, interface loopback 0. It defines a new interface, virtual interface for us on router 2. Then we define its IP address, which would be IP address 10.0.2.2 with a subnet mask of what? 24. Again, we could display the current configuration we just did to be sure the IP address has been assigned as we expected. So we simply say display IP interface. It is prudent for you to do this such that you are sure of what you are actually putting into your router, because by the time you finish and you set up things like static route and the like, it will be difficult for you to do away with some of the configuration unless of all you are wiping it out completely. That is why it will be good for you to always be sure of what you type before proceeding to the next step. So in this particular scenario, to interface 1 of the gigabit port is assigned 10.0.12.2 against a subnet mask of 24 bits, and then the loopback is 10.0.2.2, which means we are done for this particular router 2. Then we go to our final router, which is router 3. And its block of IP address is also spelled out. Remember, it is also connected to just one interface. Port 0 of router 3 is connected to router 1, but we have defined 2 loopback interfaces for it. In the topology you see in our presentation here, we have router 3 having loopback 2 and then loopback 0, such that loopback 2 could be maybe a 1, and then loopback 0 could be another network separated from our network, but also on an external interface. So we want to do this such that if we update our OSPF database, we would see the communication routing through all the routers on our network. So we change this to system-view. Then we change our router name, which is sysname, to what? RT-3, signifying router 3. And then we define an IP address for interface 0. So we say interface gigabit Ethernet 0/0/0. So it navigates to that particular port, and now we define the IP address, which would be what? IP. Remember, if you don't know the command of head, do not memorize them. We can simply use the question mark to tell the commands that are after, or that comes after a command if we are not too sure. So if you are not too sure, you simply hit the command, the question mark. You see, in this case, I assume I am not sure of what I'm typing. You would probably want to memorize things just because you see that I type them truly. It is not a must for you to memorize some of these things. So what you simply do is what? You use the question mark to tell the commands that come after a specific or a specified command. But if you know it off head too, it doesn't spoil anything. So IP address, and then we are defining for port 0, which would be, in our scenario here, 10.0.13.3. So it is 10.0.13.3 with a subnet mask of what? 24. Then we navigate back to the normal view, and then we set 2 loopback interfaces. So for the first loopback interface, I say interface loopback 0. Now we are there, and then I define its IP address to be what? 10.0.3.3 space 24. So I want to be sure, yes, my change has taken effect. Then we define the next loopback, which is loopback 2. So I say interface loopback 2. It navigates to that particular prompt, and then IP address 172.16.0.1 space what? 24. So this sums it up for router 3 configuration 2. So now we would have to define our OSPF policies on the routers from router 1, router 2, and then router 3. So IP addresses 10.0.1.0 being the broadcast IP address for router 1. Remember, router 1 resides on 10.0.13.1/24. So its broadcast IP address automatically becomes 10.0.1.0. Likewise, 10.0.12.0 becomes the broadcast IP address for router 2, and then 10.0.13.0 becomes the broadcast IP address for router 3. So we would have to update the databases of all routers on our network to know that given this particular area, say area 0 of our OSPF protocol, these broadcast IP addresses are known to this specific ID. So when a computer is searching for a service or information on our network, it is able to filter the distance or the cost within our protocol to pick the exact information in time for us. So it is this particular policy that will allow for our devices to be able to work the way we want it to work. So on router 1, we define the OSPF ID. So we simply say, remember, you don't need to be on any interface. You need to be on the main view of your configuration view in the router. So we say OSPF 1. Then the router ID for what? OSPF 1 would be used. Remember, you can use the tab key to complete a command if you don't know it offhand. I repeat. Then now we are defining what? The ID to be 10.0.1.1. That is our OSPF ID for this particular area. Now that we have defined the OSPF ID, we need to define the area. We could have multiple OSPF protocols on our network. So we could say area 0, area 1, area 2, area 3, and so on and so forth. But we are dealing with a single area for now. So we would base our configuration on area 0 for now. So it has moved us to the ID that we have specified, which is OSPF 1. So we specify the area. We just say area 0. It's as simple as that. Once we define this, it calls the block ID for OSPF area 0. Now remember, I explained in the presentation before the simulation that the OSPF does not use a class. It is classless. That is what allows for it to be able to route any block of IP address we have on our network. So we simply say for the first network, that is the block of network on the first broadcast IP given in this particular list. So we define it, define this, and define this. So we define all of them as networks within our block or our area. So network of what? 10.0.1.0 space. Then now, because it is a classless protocol, we reverse the entry of what? The subnet mask, which would be 0.0.0.255, and then we enter. So it defines the first network, and then we define the second network. Remember, I just use the top arrow key to repeat the previous command. So I simply come back and then I change the IP address here to tally with the next broadcast IP I am dealing with which would be what? 10.0.3.0. So I simply change this, and then when I hit enter, it activates for what? The second block of IP. That is the IP for router 3, but we've not entered the broadcast IP for router 2 yet. That will be our third interface or our third network to be configured. So I simply come and then I change this to what? To 2. So this sums it up for the OSPF configuration for router 1. Now we go to router 2 and then we update that too. So we realize that the other routers would reside to router 1 as the DR. The DR explained as what? The designated route. That will be the normal path everybody passes. But in case of difficulties, they would have to use the backup designated route for their information. So we go to what? Router 2. And then under router 2, we define the ID. So we would be dealing with what? The ID for router 22. So we say OSPF 1, the same ID, and then what? The router ID would be 10.2.2, 10.0.2.2. That is the gateway for the second router, which is what? 10.0.2.2. Then now, once we go on, we are within the OSPF area. Then we define the single area. Remember, the previous router was set to area 0. So this router would also be set to area 0, such that the two routers would know that they belong to the same area. It is very important you note that. So the moment I set this, you see it gives us a similar view as the previous router gave us. Then we define the networks. On this one, it is going to identify two networks. The network of 10.0.2.0 and then the network of what? 10.0.12.0. If you look at the topology, you would realize that these particular IPs I am mentioning are in play. That is why I spelled them out within the topology before we got here. Thank you. So under router 2, we define the network, which would be what? Network of broadcast IP 10.0.2.0, and then our mask will be 0.0.0.255. And then my next network will be what? .12 here. And now that sums it up for router 2. So we go to router 3 and then we define the OSPF policy for that one too. So under router 3, we come to the normal view of it, and then we say OSPF 1, and the router ID would be 10.0.3.3, the gateway of this particular router, and then we define the area, also area 0, so that it will put router 1, router 2, and router 3 within the same area. Now we define our network would be what? 10.0.3.0 space 0.0.0.255. Then we enter. Remember, that is the network we have defined for the first network, and then we define the second network on what? Router 3, because it also has two networks. So now I define the network, then the IP for here would change to from 3 to 13 in the order. So now that we have updated all these routers, they would learn from each other. So the moment the router comes on and it realizes that it belongs to area 0 of another router, it migrates its settings to that particular router, so that if there is any slight change, it will communicate to the other routers that, oh, I have received this particular change within me. So because we are all on the same area, it will be prudent you also have such information, such that we can easily reach our target. So now, in order to see if what we did takes effect, let us display the routing table of router 1, and then we see what happens. So under router 1, we simply say display IP. If you don't know the command, remember you could always use the tab key to complete it, or use the question mark to find out. So we say display IP routing table, and then we enter. So you would realize that 10.0.1.0 is the broadcast IP, which is direct on our router, and then its next hop is 10.0.1.1. So if we do a traceset, the command traceset to say traceset on our DNS or on our neighbor router, we would see the hops it would have to pass through. Now we realize that on the block of IPs there is 10.0.12.0, 10.0.1.1 defined within the first block of its IPs, which we understand fully. Then we would again see that the networks of the OSPF is completely defined within it, allowing for it to update other routers that come through it. So if we do a simple display OSPF peer, we would be able to see its neighbors. So the router identifies that maybe router 2 is my neighbor and then router 3 is my neighbor. Router 2 would identify that router 1 is my neighbor, and then router 3 would also identify that router 1 is my neighbor. So in order to find out the neighbors within your terrain, you simply say display OSPF peer. So when you say display OSPF peer, what happens? It says OSPF process 1 with router ID 10.0.1.1. So any router with the ID 10.0.1.1 becomes a peer or becomes a neighbor within its particular terrain. It will be able to identify it. Now, I know this is a bit of work for you, but if you fully understand what OSPF is about, this is a simple way to integrated. So once you have the OSPF, you can then define a dynamic or a static route on your network such that your routing pool would be able to move flexibly. In my previous video on static routes, you would be able to now see that this same protocol is implemented there, and then your static route can be added to the configuration we have. Thank you for watching, and do remember to subscribe to my YouTube channel for more videos. Bye.